in the xy plane, at what 2 points does the graph of y is equal to the quantity x plus a times the quantity x plus b intersect the x-axis? So here we are given an equation for what looks like a non-linear shape. And one thing I've learned from the Gmat is usually if you're trying to, if you're given a nonlinear equation, you don't really have to be able to visualize what type of shape that is, or usually don't have to draw it out on paper. And so in this case, I think this is a parabola of some sort, although I'm not really even sure. And so usually when they give you coordinate geometry questions with non-linear graphs, it's really just an algebra question. You sort of just have to be able to relate your equation to the coordinate plane algebraically. And so in this case, they're asking us for the x-intercept of this graph. And so what is the x-intercept? Well, that is just the value for x when you set your y value equal to 0. So here we're saying 0 is equal to x plus a times x plus b. And so what would our x coordinate be? That gives us a value of 0. So that is when x is equal to negative a, or x is equal to negative b. In other words, our x-intercepts are going to be negative a, 0, and negative b, 0. So if we're trying to find what these coordinates are, we just need to find negative a and negative b. But since it is data sufficiency, if you want to just rephrase this as what is a and b, you can do that. Because if you can find a and b, you can certainly find negative a and negative b. So with that in mind, this is what we are looking for. And statement 1 says a plus b is equal to negative 1. And so by itself, this will be insufficient. We cannot solve for a and b based on this. Statement 2 says the graph intersects the y-axis at 0, negative 6. So here we are given the y-intercept, and so that is the y value when the x value is equal to 0. So we can plug that into our equation to say negative 6 is equal to, then 0 plus a is just a, and times 0 plus b is just b. And so here we are given just this equation, a times b is equal to negative 6. But again, by itself, we can't solve for a and b. There's multiple values for a and b here, so that will be insufficient. And now we're looking at them together. And now we have two equations, and we also have two variables. And so based on that, as long as our equations are unique, which they look like they are, we should be able to solve for those variables. So based on that alone, if you were confident, you could just move on, confident that you should be able to solve for a and b without actually doing it. Now, I would say, again, if you have the time, it doesn't hurt to do it, and certainly when you're reviewing. So let's try and solve for a and b here. And one thing you can do is, instead of substituting, is just recognize that there aren't really that many options, at least if you're only looking at whole numbers, of two things that multiply to negative 6. And so we just need to find the pair that sums to negative 1. And so our options are really just what? 2 and negative 3. And then every pair is going to have its reverse, right? So you can also have negative 2 and positive 3. And then there's also 1 times negative 6, and then you also have negative 1 times positive 6. And so which one of these sums to negative 1? And this does not. This certainly does not. This is positive 1, so that does not work. And so we're just left with these two values. And remember, these are our values for a and b. And so now one thing people might do is say, well, we don't know which one is a and which one is b, therefore it's still insufficient. But that does not matter, because we just need, if one is, so So if A is equal to -2, then B is equal to +3. And if A is equal to +3, B is equal to -2. But regardless of which one of these is the case, our x-intercepts are still the same, right? I'm sorry. These are our values for -A and -B. Our x-intercepts are still -2, 0, and 3, 0. So C.